Good morning, my students. We are going to study the alternating circuits. Alternating circuits. This chapter can be classified into four parts. The first stage in which we will going to study hot wire meter. The second stage, we will study RLC circuits. The third stage, we are going to study oscillating circuit. And in the fourth stage, we are going to study the resonance circuit. At first, what do you know about the alternating current? Alternating current. It is the current which changes from zero to maximum in each quarter cycle, then returns to zero in the second quarter cycle, and move to its maximum value and reverse its direction. This is the positive direction, this is the negative direction, and returns to zero again. This graph represented by sine curve, in which the intensity changes each quarter cycle. The direction of the current changes each half cycle. This is called alternating current or AC current. It is the current which changes its intensity and direction periodically with time in sinusoidal curve. At the intensity or electromotive force, because electromotive force is directly proportional with the current intensity. It changes from zero to maximum value, then to zero to maximum value in the opposite direction, to zero, forming one complete vibration during each complete revolution of the coils of dynamo. The definition of frequency of alternating current. There is a difference between the frequency and the frequency of alternating current. The frequency means the number of complete revolution per second, while frequency of alternating current, the number of complete vibrations or revolution done by alternating current in 1 second. Another define the number of complete revolution done by coils, dynamo's coil in 1 second. Frequency can be calculated from the following rule: number of complete revolutions or number of complete oscillations or number of complete vibrations divided time in 1 second. The unit for measuring it, cycle per second or hertz. Hz is called hertz. Another define for effective value of alternating current. If you have a conductor carrying dielectric current, DC current, it will produce quantity of thermal energy. When AC current passes through the conductor, produces the same quantity of heat or thermal energy. If the thermal energy resulting from the dielectric current equals the thermal energy produced from the alternating current, this means that alternating current has effective equal the value of dielectric current that generates thermal energy equal to the thermal energy generated by passing alternating current in the same conductor in the same time. Another define, it is the value of dielectric current generates the same power generated by alternating current. There is a third point is called electric power. Electric power equal W over T or E over T. It is the work done per unit time or rate of doing work or energy, rate of consuming energy in 1 second. In 1 second. This power directly proportional with the effective value squared at constant resistance. At constant resistance. This is called alternating current. What is the advantages of the alternating current? What is the advantages of the alternating current? Number one, voltage can be stepped up or stepped down using transformer. While direct current is fixed, we cannot step up or step down. Alternating current can be converted into direct current, but direct current cannot be converted into alternating current. Alternating current has thermal effect like direct current, which is passed through ohmic resistance. Passing through ohmic resistance due to the passing of electric current, which are electrons or charges, make collision with the electrons or molecules of the conductor by making friction, which produce heat energy in the form of thermal effect of the current. Does not depend on the direction. The heat energy does not depend on the direction of the current. Both of them produces heat energy. Heat energy does not depend on the direction of the current. Direct current produces heat energy. Alternating current produces heat energy. So it can be used to operate heaters and light lamp. From the advantages of the alternating current, it can be used to operate some electric devices, which is based on variable magnetic flux, like transformer and induction furnace. Transformer which step up or step down alternating voltage, while induction furnace produces eddy current which used to melt metals, due to the vibration of magnetic flux in dense solid. But it can be used in electrolysis. Direct current can be used in electrolysis, while alternating current cannot be used in electrolysis or electroplating or extraction of metal from their ores. From advantages of alternating current, can be transmitted through long distances without large rate of electric energy and thermal energy in the wire. A step-up transformer is used at the generating stations to increase the voltage and decrease the current, so the power lost through the wire due to the ohmic resistance equal I squared R. Then step-down transformer is used in distribution station to decrease the voltage to 220 volt and increase the current to suitable value. Now we are going to make a comparison between direct current and alternating current. Direct current, unidirectional current of constant direction, constant value, move in a straight line. While alternating current, it is the current which changes its intensity and direction periodically with the time in sinusoidal curve. Direct current can be used in the electrolysis produced by cells, which convert chemical energy into electrical energy. Direct current, its intensity measured by moving coil galvanometer. When direct current passes through coil between two poles of the magnet, magnetic forces will be produce torque equal and opposite forces, and there is a distance between them, so magnetic torque equal tau equal pi n sine theta. This is the value of the magnetic torque. Tau is called torque. When direct current passes through a meter coil between two poles of the magnet, magnetic forces will be produce torque, makes the pointer and the coil will rotate either clockwise or anti-clockwise direction. This direction depending on the direction of the measured current. The torque depends on the current intensity. Why? Because the magnetic flux density is constant, the cross-section area is constant, the number of turns of the coil is constant, the angle is constant, because it contains concave shape which make the torque always constant. While in case of alternating current, can be used in some electrical devices based on thermal effect or variable magnetic effect of the electric current. Example, heater, transformer, induction furnace, produced by dynamo or generator, which convert mechanical energy into electric energy. Its intensity can be measured but cannot be measured by using moving coil galvanometer, because it changes its direction each half turn, each half cycle, so the pointer will vibrate at low frequency. What is the meaning of it? Alternating current, when we use moving coil galvanometer, the pointer vibrates at two sides, move and does not stop, so we cannot measure the intensity of very weak alternating current. When the frequency of the alternating current is high, the pointer stops and does not change due to inertia. This is the first part to study the alternating circuit. Goodbye and good luck, my student.